Hello friends, here in this video we will see a problem on calculation of MI, that is moment of inertia, for the given section. And here is the question that determine the MI of channel section shown in figure about the centroidal axis. So here is the C section which is given, and for that we have to calculate MI about the centroidal axis. It means here the question is we have to find out Ixx and Iyy. Now, how to calculate Ixx and Iyy? The first step is we should know where the centroidal axis is located. That is, we should know where is x-axis and y-axis. And for that purpose, I have divided this channel section into three rectangles. Like for example, this will be rectangle 1, then rectangle 2, and next this would be the rectangle number 3rd. So after dividing it into three rectangles, now we are going to calculate the values of x bar and y bar, because we want to locate the x-axis and y-axis. And once we have located the x and y-axis, we can say that the centroid has been located. And for finding the MI, the first thing which is required is the centroid. So let us get started in this problem. Solution. Here I'll say that first, since the location of y-axis is given by x bar is equal to a1x1 plus a2x2 plus a3x3 upon a1 plus a2 plus a3. Now I'll keep this as the first equation. Next I will go on finding all these values here. So the first thing is area 1, which is a1, and that will be equal to, here we have the first rectangle, its width is 150 and height is 15, so it is 150 into 15. So area 1 is 2250 mm square. Next, area 2, that is equal to 10 into 125. So it is 1250 mm square. Next, area 3, it is 100 into 10. So it is 1000 mm square. Then x1 will be equal to, x1 is the location of y-axis for the first rectangle, and the y-axis of the first rectangle will be at half of 150. So that will give us x1. Next, x2 will be the y-axis of the second rectangle, and it would be located at half of 10. So that is 5 mm. Next, x3 will be the location of y-axis for the third rectangle. It would be located at half of 100. So that is 50 mm. Now, after getting these values, we can put them in equation 1. So therefore, put all values in equation number 1. So here we have x bar is equal to a1 into x1, that is 2250, into x1 is 75, plus a2 is 1250, into x2 is 5, plus a3 is 1000, into x3 is 50, divided by a1 is 2250, plus a2 is 1250, a3 is 1000. So I am getting x bar. Therefore, x bar value comes out to be, it is 50 mm from LHS, that is left hand side. Now I will even get X bar from the right hand side. So that will be the total width, if we see in the problem, is 150, that is from the origin. So from 150 we will subtract 50, that gives me 100 mm from RHS right hand side. So here now we know the location of y-axis, so we can locate it onto the diagram. Here we have 50, this is 100. So now this is the location of y-axis at X bar is equal to 50 mm, and from right hand side it is X bar is equal to 100 mm. So here we have the y-axis. This is the y-axis for the complete C section. Now similarly we would be calculating the x-axis, and x-axis we can calculate by using the formula of y bar. So I'll say that after this, since the location of x-axis is given by y bar is equal to a1 y1 plus a2 y2 plus a3 y3 upon a1 plus a2 plus a3. I'll keep this as second equation. Now therefore we need y1 y2 y3 values. Y1 is the location of x-axis for the first rectangle, and its x-axis will be at half of 15, so that is 7.5 mm. Next, y2 value will be, since we have rectangle 2 after 15 mm, so it is 15 plus at half of 125 we would be having the x-axis for the second rectangle. So here this value of y2, it comes out to be 77.5 mm. Similarly y3, it is starting, the third rectangle is starting after 15 plus 125, that is 140, and its x-axis is exactly at half of 10, so 140 plus half of 10, so y3 is 145 mm. So now after getting y1 y2 and y3 values, I can say that therefore put all values in equation number second. So therefore y bar will be equal to, area 1 we have found out, it was 2250 into y1 is 7.5 plus area 2, that was 1250 into y2 77.5 plus area 3, that was 1000 into y3 is 145 divided by area 1 plus area 2 plus area 3. So if I calculate from this, I'll get my answer of y bar as 57.5 mm from bottom. Now after getting y bar from bottom, I can say that therefore y bar is equal to, since we had taken all the references from bottom, so we have got y bar from bottom, that is 57.5. Now if we want y bar from top, and that is required in the calculation of moment of inertia, so we need to have y bar from top as well. So what we will do, add these values, that is 15 plus 125, that is 140, plus 10, 150. So from 150 I am going to subtract the value from bottom, that is 57.5. So here I get y bar as 92.5 mm from top. So after getting the y bar values, we can say that the x-axis have been located. So the x-axis is at 57.5 mm from bottom and 92.5 mm from top. And once we have located the x-axis and the y-axis, wherever they intersect, that gives us the centroid. Now, hence we have located the centroid, and once we have located the centroid, then we can start with the calculation of moment of inertia. Now here there are two questions, Ixx and Iyy, which we have to find out. So we'll start with Ixx, that now since Mi about horizontal centroidal axis is given by Ixx is equal to Ixx1 plus Ixx2 plus Ixx3. Keeping this as the third equation. Now I'll say that therefore Ixx1 is equal to Mi about centroidal axis for rectangle 1. Therefore Ixx1 is equal to Ig1 plus area 1 into h1 square. This is by parallel axis theorem. And why we are using parallel axis theorem is because the x-axis for complete C section is passing through 57.5 mm distance, but if we look at the x-axis for rectangle number 1, that is at a distance of 15 by 2, that is 7.5 mm from bottom. So there is the difference between the two axes, and that difference is called as h1. And here we are calculating the moment of inertia for this rectangle number 1 about the centroidal axis. So that is why we have to use parallel axis theorem. If the distance between the two axes would have been 0, that is they are passing through the same line, then there is no need of parallel axis theorem. But here, since there is some distance, that is why we have to use the parallel axis theorem. So here I have written Ig1. So what is Ig1? Therefore Ixx is equal to, now Ig1 is the moment of inertia for rectangle number 1 about its own axis, which is here. I'll call it as axis 1 1. So about this 1 1 axis, which I am calculating the moment of inertia, that would be called as Ig1. So Ig1 is equal to BD cube by 12 plus area 1 is B into D into H1 square. So therefore B and D, what is B here? For the first rectangle, B is 150 and D is 15. So 150 into 15 cube by 12 plus 150 into 15 into h1. h1 is 57.5 minus 7.5 square. So therefore ix6 value, if I calculate this throughout, it comes out to be, that is 5.67 into 10 raised to 6 mm raised to 4. That is the answer of ix6 1. Now similarly I'll calculate ix6 2. What is ix6 2? It is the mi about horizontal centroidal axis for rectangle number 2. So therefore ix6 2 is equal to ig2 plus area 2 into h2 square, and this has also come from parallel axis theorem. Now therefore ix2 will be equal to, as we can see, the x-axis of a rectangle number second, it is passing at a distance of 72.5 from bottom, that is the distance here. This is 72.5 mm from bottom, that is for rectangle number second. But the x-axis for complete C section is passing through 57.5 mm distance from bottom. It means now there is the distance between two axes, and this distance would be called as h2. So that is why we are using parallel axis theorem, because there will be some distance between the two axes. So now here we have to calculate ix2 by using parallel axis theorem. I have used ig2. ig2 is the mi for rectangle number 2 about its axis, that is axis 2 to which I have marked. It is at 72.5 mm distance. So ig2 will be bd cube by 12, area is b into d into h2 square. So therefore ix2 is equal to, now for the second rectangle, b is 10, d is 125, h2 is the distance which is 72.5 minus 57.5. So from this I'll get ix2, and my answer is, it is 1.91 into 10 raised to 6 mm raised to 4. Now the next thing is we want to calculate ix3. So therefore ix3 is the mi about horizontal centroidal axis for rectangle 3. So now ix3 will be ig3 plus area 3 into h3 square. This is by parallel axis theorem. Now if we see the diagram, then the x-axis of rectangle 3, it is here, I'll mark it as 3 and 3, x-axis for the rectangle third, but the x-axis of complete C section is located at 92.5 mm distance from top, and here the distance of this x-axis is 5 mm from top. So it means the two axes, they are not passing through the same line, there is some distance, and that distance between these two axes, that is from here till the x-axis of the complete C section, this would be called as h3. So that is why we are using parallel axis theorem. If this distance would have been 0, then no need of parallel axis theorem. So now I'll say that therefore Ix63 will be equal to Ig3 is BD cube by 12, because it is the moment of inertia for rectangle 3 about its x-axis, which is axis 3 3, plus area is B into D into h3 square. So therefore Ix63 is equal to B and D values. For the third rectangle, B is 100, D is 10. Now h3, it is the distance between the two axes here. So it is 92.5 minus 5. So from this, if we calculate, the answer of Ix63 is 7.66 into 10 raised to 6 mm raised to 4. So after finding all these three values, we can put them in equation number 3rd to get Ixx, because we know Ixx1, Ixx2, Ixx3. So after this, I'll say that put all values in equation number 3. So therefore Ixx is equal to, Ixx1 was 5.67 into 10 raised to 6. Ixx2 1.91 into 10 raised to 6. Ixx3 7.66 into 10 raised to 6. So after adding them, I'll get my answer of Ixx, which is, it is 15.24 into 10 raised to 6 mm raised to 4. So here is our first answer. That is, we have found out Ixx. Next, similarly, Mi about vertical centroidal axis is given by Iyy is equal to Iyy1 plus Iyy2 plus Iyy3. This will be the fourth equation. Now, in that, the first thing is Iyy, and Iyy is equal to Mi about vertical centroidal axis for rectangle number 1. So therefore Iyy1 is equal to Ig1 plus area 1 into h1 square by parallel axis theorem. So therefore Iyy1 will be equal to, now if we look into this diagram, then the y-axis of rectangle number 1, its width is 150. So y-axis will be at half of 150. So the distance of the y-axis for rectangle 1, it is at a distance of half of 150, that is 75 mm from left hand side. But if we see the y-axis of complete C section, that is at x bar is equal to 50 mm from LHS. So it means there is the distance between two axes, and this distance would be h1. So that is why we are using parallel axis theorem. If the y-axis of rectangle 1 and the y-axis of the channel section were passing through the same line, that is distance would have been 0, then there is no need of parallel axis theorem. But here we will use parallel axis theorem. So the first thing is Ig1. Ig1 is the moment of inertia for rectangle 1 about its own y-axis, and that will be written as db cube by 12 plus area 1 is b into d into h1 square. Now we need to find out the values of Iyy1. So therefore Iyy1 is equal to d and b values. Here for the rectangle number 1, d is 15 and b is 150. So 15 into 150 cube divided by 12 plus b into d. Now h1 is the distance, as I have explained, between the y-axis of rectangle 1 and the y-axis of complete section. So it is 75 minus 50 because we want this distance as h1. So from this we will get Iyy1, and the answer is 5.625 into 10 raised to 6 mm raised to 4. Now in a similar manner I will calculate Iyy2. So therefore Iyy2 is equal to mi about vertical centroidal axis for a rectangle second. So therefore Iyy2 is equal to Ig2 plus area 2 into h2 square. This is by parallel axis theorem. So now Iyy2 is equal to Ig2 is db cube by 12 plus area is b into d. h2 is the distance between the y-axis of given C section and the y-axis of rectangle 2. So rectangle 2, its y-axis is here, that is at half of 10. So the distance h2 is the difference between the two y-axis. This is h2. So it is clear that it is 50 minus 5 because this distance is 5 mm. So that gives us h2. So therefore here first I'll write down h2 square, and then Iyy2 is equal to d and b values. For the second rectangle, d is 125, b is 10, area is 1250, h2 is 50 minus 5 whole square. So therefore Iyy2, it comes out to be 2.54 into 10 raised to 6 mm raised to 4. Next we need to calculate Iyy3. So therefore Iyy3 is equal to mi about vertical centroidal axis for rectangle second, for rectangle third. Therefore Iyy3 is equal to Ig3 plus area 3 into h3 square by parallel axis theorem. So therefore Iyy3 will be equal to Ig3 is dB cube by 12, area is B into D, H3 is the distance. Now if we look into this, the y-axis for rectangle for the complete section is at 50 mm from left hand side, and similarly the y-axis for rectangle number 3, that will also be at half of 100, that is 50 mm. And since both the y-axes are passing through the same line, then there is no distance, so h3 becomes 0. So once h3 is 0, then there is no need of parallel axis theorem. The formula is reduced to dB cube by 12. So hence Iyy3 will be equal to D and B values. Here D is 10 and B is 100. So 10 into 100 cube divided by 12. So Iyy3, the answer is 833.33 into 10 raised to 3 mm raised to 4. After getting all these values, we can put them in equation number 4 to get Iyy. That is, here we have that equation number 4, in which we will put Iyy1, Iyy2 and Iyy3. So therefore, put Iyy1, Iyy2 and Iyy3 in equation 4. So therefore, Iyy is equal to Iyy1, that was 5.625 into 10 raised to 6. Then Iyy2, it was 2.54 into 10 raised to 6. And Iyy3 we have calculated just now, 833.33 into 10 raised to 3. So after adding all of them, we get Iyy, and the answer is 841.50 into 10 raised to 6 mm raised to 4. So this is the second answer. So here in this video we have seen how to calculate the moment of inertia about centroidal axis for the given channel section, and with this we complete the question.